On October 29, 2025, something impossible happened. A wanderer from another star, 3I Atlas, passed near our Sun and exploded not in fire or dust, but in a shock of blue light. No fragments. No debris. Only water vapor streaming out in volumes no one could explain. When the James Webb Space Telescope turned toward it, it found something haunting: a shell, about 50 to 65 feet deep, irradiated, hardened, as if time itself had sealed it. Billions of years asleep, and then this. Something within that shell changed when sunlight struck it. The question wasn't what caused the burst, but why an object designed to last eternity awoke so violently near our star. The story began with a flash in the dark between worlds. An interstellar object moving faster than a bullet erupted in light no one expected. Not the soft glow of a comet warming near the Sun, but a violent surge that lit up telescopes across Earth. They named it 3I Atlas. On that morning, it reached perihelion, its closest approach to the Sun. Usually, comets brighten in predictable steps. Ice warms, gas vents, brightness rises slowly. Astronomers have seen it countless times. But 3I Atlas didn't follow the rules. It brightened sharply days before perihelion, as if something inside had been triggered. At 1.4 astronomical units, around 210 million kilometers from the Sun, it was still farther out than Earth, yet flared as though it had crossed an invisible line. It traveled at 60 kilometers per second, too fast for capture, on a hyperbolic path. It came from somewhere else, and it was leaving for good. But its look made it unforgettable. Its light was bluer than the Sun itself. The spectra revealed carbon and amidogen molecules in concentrations that defied normal comet chemistry. Then came the tail paradox. Every comet we've seen, Halley, Hale-Bopp, Neowise, leaves a tail of dust and gas. 3I Atlas showed none. Bright, yes, but leaving no trail behind, like running across sand and leaving no prints. Astronomers asked, where's the dust? Is this even a comet? Later, a tail appeared, weak and late, deepening the mystery. Why delay? Comets don't wait. The anomaly broke models built over centuries. Brightness curves, dust ratios, gas emissions all shattered. The implication was clear. Either 3I Atlas was a statistical outlier, or we'd hit something new. If it's a fluke, the models hold. If not, the models are wrong. The difference matters. Because it means the void between stars could be full of things we don't understand, objects born under unknown conditions, shaped by forces beyond our theories. Maybe even engineered. When JWST aimed its infrared eye, it found a surface transformed. A shell, 50 to 65 feet thick, hardened by billions of years of cosmic ray bombardment. Outside any star's protective bubble, cosmic rays, protons and heavy nuclei accelerated by supernovae tear through matter, smashing molecules, rearranging atoms, creating new compounds. Over billions of years, they turn ice and rock into a chemically altered crust. Models predict depths of 15 to 20 meters, and 3I Atlas matched them almost perfectly. That means we aren't seeing the real object. We're seeing a mask, the surface rewritten by time and radiation. Its true core lies buried, untouched since its birth. This flips our assumptions. Interstellar objects aren't pristine fossils of alien systems. They're scarred relics, rewritten by cosmic weather. Spectroscopy even showed metal anomalies. The ratio of nickel to iron didn't match solar system norms. Some scientists blamed radiation effects, others different birth chemistry. Either way, the surface told a distorted story. To know what 3I Atlas truly is, we'd need to burn or break through that shell. Solar heating might do it, or not. The crust might hold. But what if the shell wasn't only weathering? What if it served a purpose: insulation, regulation, protection? What if it was designed? We don't have proof. Yet the possibility sits there, uncomfortable and persistent. The crust might not be random. It might be function. And if so, nature or not, the mask hides intent. As more data came in, the oddities multiplied. High carbon monoxide levels. Excess water vapor. Nickel stronger than iron. 33 billion tons of mass, half again as large as Halley's Comet. For something unbound to any star, that's unusually massive. Too big for easy ejection. Too precise a path. Some suggested chance. Others whispered design. Its orbit was strange too, hyperbolic but almost aligned with the ecliptic, the same plane where planets orbit. Interstellar objects should come from random angles. This one didn't. Maybe coincidence. Maybe not. Each anomaly alone could be explained. Together, they broke the model. The rapid brightening, delayed dust, blue emission, metal ratios, mass, and orbit taken together, they painted a picture of something that didn't belong. Scientists split. Some said patience. We've only seen 3 interstellar visitors, Oumuamua, Borisov, and now Atlas. Too few to generalize. Others said stop hiding behind statistics. The data refuses to fit the easy story. Maybe some of these visitors aren't natural at all. If Oumuamua was strange, Borisov normal, and Atlas strange again, but differently, then maybe strangeness itself is the pattern. The dust tail deepened the puzzle. Early on, there was gas but almost no dust. Later, jets erupted, sudden, directional, even aimed toward the sun. That shouldn't happen. Radiation pressure pushes dust away, not toward. The crust might have cracked under pressure, releasing trapped gases in bursts. Or maybe the whole structure was something else entirely. Imagine an iceberg that glows but refuses to shed flakes until it bursts from within. That's 3I Atlas. The late jets, the blue light, the thick crust all point to a hidden interior structure. Maybe layered, maybe engineered, maybe both. Some scientists began asking the question outright, what if this is no comet? What if we're watching a relic, a shell, a vessel, an artifact disguised as ice? Not alien fantasy. Engineering built to last. A probe wrapped in shielding to survive the radiation between stars. To us it looks like a comet. To them, maybe, it was camouflage. The case isn't proven. There's no signal, no code, no mechanism. Just patterns that don't fit. But good science doesn't hide from hard questions. If an object behaves unlike any comet we know, maybe it isn't one. Others took a different route. Maybe it's not artificial but ancient, a planetary seed. A failed planet core ejected before it could grow. A fragment wandering between systems, never captured, wearing armor forged by cosmic rays. That idea, interstellar seeding, answers another riddle in planet formation, the meter-size barrier. Maybe planets sometimes begin from imported fragments like this. If true, 3I Atlas could be a building block that never found a home. A piece of a lost world, carrying chemistry from another sun. A frozen seed that, if captured long ago, might have built a planet or seeded life. The artificial idea won't die either. Avi Loeb of Harvard has argued it shouldn't. He doesn't claim certainty, only that the data demands all explanations stay on the table. Unusual metals. Massive size. Aligned trajectory. Thick crust. Each can be explained, but together they justify the question, could this be an artifact? What would an interstellar probe look like? Not like Voyager. Not fragile. You'd make it dense, shielded, perhaps encased in ice to survive eons. From afar it would look exactly like a comet. It would vent when heated, mimic natural behavior, and protect whatever was inside. No proof. But enough to warrant asking. If natural, 3i Atlas reshapes our understanding of planet formation. If artificial, it changes everything about our place in the galaxy. It would mean intelligence once crossed the stars and left evidence that still drifts among them. Either way, transparency matters. Loeb and others have urged NASA and observatories to release full data, spectra, trajectories, everything, so the global scientific community can analyze without filters. The truth hides in the details. As of late 2025, the object is fading, racing away at 60 kilometers per second. Astronomers watch the outgassing, the brightness, the trajectory. If it fades predictably, it supports the comet theory. If it doesn't, if the jets persist or new emissions appear, then something deeper is at work. No probe is heading to intercept it. It moves too fast. All we can do is watch as it vanishes into the dark. Two paths lie ahead. One ends with an unusual but natural interstellar comet. The other, with the first trace of engineered intelligence beyond Earth. Parallel to all this, a new kind of observer is rising. AI systems now scan telescope data, spotting anomalies faster than humans. Machine learning trained on years of sky surveys can flag movement, outbursts, strange behavior in real time. If such systems had been fully operational earlier, we might have caught Atlas's awakening the moment it began. In the future, they might even learn to recognize patterns that look artificial, controlled acceleration, structured signals, or behavior no comet could mimic. At the same time, new research on cosmic rays is changing how we interpret what we see. Experiments show radiation transforms small bodies far more than we thought. High-energy particles carve meters-deep scars, rearranging chemistry, building dark crusts, synthesizing complex molecules. The crust on 3i Atlas fits those models perfectly. The outer shell isn't just damage, it's transformation. This means we're never seeing interstellar objects as they were, only as they've become. Their surfaces are rewritten by the void itself. To reach their truth, we'd need to go beneath the crust, to the untouched layers below. 3i Atlas might vanish soon, slipping back into the dark. But it's left us with a challenge that won't fade, to rethink what's possible, to look deeper than the surface, and to ask, every time a light moves through our sky, what if we're not seeing an object at all, but a message? As 3i Atlas recedes from the inner solar system, the light begins to fade, but the questions do not. Its blue coma still lingers faintly in the data streams, a smear of photons that refuses to fit the models. Every major observatory, JWST, ALMA, Keck, Subaru, keeps its sensors trained on the vanishing trace, hunting for one last anomaly before it disappears beyond reach. Somewhere out there, between Mars and Jupiter's orbit, the visitor drifts back into shadow, silent but defiant, leaving behind equations that no longer balance. The numbers themselves are unsettling. Brightness falls too slowly. The outgassing rate, when corrected for solar distance, doesn't decline as expected. The coma, which should contract as volatiles freeze, remains inflated. Something inside is still releasing heat. That should be impossible at this distance. Comets fade fast once the sunlight weakens. 3i Atlas hasn't. It's as if an ember burns within. Spectroscopy from late November shows faint emission lines shifting in intensity. Molecules appearing that weren't present before, complex hydrocarbons, traces of formaldehyde, ethane, acetylene. Chemical fingerprints that don't belong to a frozen, exhausted comet. These are products of active chemistry, perhaps reactions in subsurface pockets triggered by internal heat or residual radiation. It could be mundane physics. It could be something else. The crust, the 20-meter thick shell of processed matter, is under stress. Thermal expansion and outgassing fracture it from within. Observers report bursts, localized plumes, faint but sharp, as if pressure vents are opening in sequence. One jet near the sunward pole lasted 12 hours, releasing a concentrated spray that shifted the object's path by a measurable fraction of a kilometer per second. Non-gravitational acceleration again, but inconsistent with visible outgassing direction. The math doesn't match. There's a moment, mid-November, when the light curve wobbles, small but distinct. Some call it a rotation effect. Others wonder if it's signaling a periodicity too regular for chance. Every 3 hours, a dip, then a peak, like a heartbeat hidden in the data. Statistically, it could be rotation, but it fits no consistent spin model. Too smooth. Too even. It repeats again 2 days later. Telescopes check their calibration. The pattern persists. No one says the word signal publicly. The field learned its lesson from Oumuamua. But in private threads and encrypted channels, scientists compare notes. Timing, amplitude, wavelength range. Nothing clear enough to claim, but enough to keep them awake. Enough to make them doubt. Meanwhile, AI systems running at Caltech and ESA's Gaia pipeline flag anomalies in trajectory residuals. The algorithms were trained to detect comets with non-gravitational forces. Atlas shows a pattern the neural nets label unclassified. A classification that didn't exist before. Data transparency becomes a flashpoint. NASA releases partial telemetry from JWST. European agencies hold back until peer review. Independent analysts demand raw spectra. AVI-Lab publishes an open letter urging unrestricted release. If we want truth, he writes, we must face the data unfiltered. Critics call him reckless. Supporters call him the only one asking the right questions. By December 2025, the object is dimming beyond reach of amateur scopes. Only large facilities can track it now. The public loses sight, but behind closed doors, the analysis deepens. The spectral slope flattens. The nickel-to-iron ratio diverges further. The residual velocity increases by fractions, tiny, but measurable. A constant outward push, like something still venting or adjusting. Some theorists propose radioactive decay as the source. Others mention piezoelectric effects, electrostatic discharge across the crust, or latent chemical energy from trapped radicals. Each explanation fits one anomaly but breaks another. The pattern refuses to settle. By January, the chatter shifts to what comes next. If Atlas fades into the dark, its lessons stay. The telescopes that watched it are upgrading. Machine learning filters are retrained on its signature. The next interstellar visitor will not escape unnoticed. AI will find it sooner. At the same time, the lab work on cosmic ray weathering accelerates. New experiments bombard mixed ice samples with heavy ions, mimicking billions of years in months. The results are startling. Layers form with microchannels and conductive veins, natural, but eerily ordered. Under repeated exposure, some samples self-organize into complex lattice structures capable of storing charge, even emitting radio noise when stressed. Accidental antennas made of cosmic frost. That discovery ripples through the 3I Atlas debate. Maybe the crust's behavior isn't artificial, just an emergent property of extreme radiation chemistry. But if natural processes can mimic design, what happens when the line between the two blurs? A paper appears in Nature Astronomy, Emergent Structured Layers in Interstellar Ice Analogues. It concludes that radiation can induce self-ordering up to 30 meters deep in mixed carbon or water ices. The final paragraph reads, if such a layer existed on 3I Atlas, it could act as both shield and regulator, storing and releasing energy episodically. To distant observers, this might appear as periodic outgassing or controlled jets. That's the thing about data. It doesn't care about comfort. It doesn't care if the explanation feels alien or ordinary. It only insists on consistency, and 3i Atlas refuses to give it. By early 2026, the object fades past magnitude 27, essentially invisible. A handful of radio arrays still listen, just in case. Nothing conclusive. Then, in February, one last flare. A faint rebrightening. Temporary. A single spike in brightness lasting 20 minutes, too short for solar reflection, too long for random noise. It vanishes as quickly as it came. After that, silence. The interstellar traveler is gone. But its wake lingers. In observatories around the world, new surveys are being built. AI pipelines tuned to detect any blue emission anomaly. Algorithms trained not only to spot light but to question it. And somewhere in a data cluster at Harvard, a model runs continuously, simulating what billions of years of radiation could do to a hollow object with layered shielding. It's labeled Atlas 9. Astronomers continue to argue. One camp says 3i Atlas was a natural relic, a frozen planetary seed scarred by the cosmos. Another says the evidence points to something more deliberate. Neither side has proof. Both have conviction. The truth, perhaps, lies in the middle. Between nature and intent. Between physics and purpose. Between what the cosmos makes and what it keeps making until the difference disappears. 3i Atlas is gone now, a dim pixel slipping beyond the heliosphere, out where the solar wind fades and the cosmic rays reign again. Its crust will thicken once more. The blue glow will die. Maybe, in another billion years, it will pass near another sun and wake again, shedding a new burst of light to another civilization that watches, confused and fascinated, asking the same question we do now. What was it? A relic? A seed? A machine? Or something in between, something the universe built itself to remember? In the months after its disappearance, a quiet obsession takes hold across the scientific world. Data teams in Hawaii, Chile, and Maryland keep reanalyzing the same frames from October 2025. The same photon streaks. The same residuals. Each new filter applied, each noise reduction run, produces whispers of new shapes, patterns inside the coma that weren't seen before. A few think they see geometry. Angles too straight. Edges too defined for a chaotic dust plume. One team at the European Southern Observatory isolates a pattern repeating at 3-degree intervals in the brightness map. A symmetry hidden in chaos. Statistical noise, say some. Artifact, say others. But a small group, engineers more than astronomers, see design principles they recognize: regular distribution, energy optimization, rotational stability. Things humans use in machines. The idea spreads quietly. They call it the Atlas lattice. The structure may be coincidence, but it forces new questions. Could radiation, pressure, and heat naturally sculpt repeating forms? Or is there a threshold where chaos produces order not by intelligence, but by inevitability? By mid-2026, two camps have crystallized. The first believes 3i Atlas is natural but formative. A planetary embryo that drifted for billions of years, gaining a hardened crust until its chemistry became self-regulating. A dead world seed that never found a star. The second believes Atlas is evidence, not of aliens, but of an intelligence older than our definitions. A system that builds itself from physics, not biology. A machine born from cosmic law. They debate in conferences and journals, but the lines blur fast. The data doesn't cleanly support either view. Every new analysis finds something that undercuts the last. A few theories rise and fall within weeks. None stay. Then, in late 2026, the Vera Rubin Observatory releases its full-sky dataset. Hidden in those petabytes of images are traces of 3 faint, fast-moving objects. Not comets. Not asteroids. All hyperbolic. all heading roughly along the same galactic vector as Atlas once did. They're fainter, smaller, but their light curves echo the same early pattern: sudden brightening, blue spectra, weak dust tails. A pattern. The community goes quiet for a week. Then the arguments start again, louder this time. Maybe the interstellar medium is full of these things. Maybe Atlas wasn't unique. Maybe it was a type, not an anomaly. AVI Lub writes another essay: patterns are evidence. Not proof, but direction. The line trends globally. Funding follows. Programs once fringe become mainstream. NASA and ESA announce joint missions to design rapid response interceptors, small autonomous craft that can launch within weeks of detection and rendezvous with interstellar visitors. The proposed name for the first mission, Atlas II. The goals are simple. Capture close-range spectra. Map the crust. Detect heat. Photograph the nucleus. Find out what these travelers truly are before they vanish again. Meanwhile, labs keep testing cosmic ray effects. A team in Japan manages to simulate interstellar radiation exposure for compressed ice carbon samples. After months of bombardment, the samples begin producing electric discharges, tiny pulses that repeat with a rhythm tied to material strain. Nature creating signal from stress. The line between communication and chemistry blurs further. Some physicists start to propose a new class of matter behavior: auto-resonant crystallization. Structures that, under constant radiation input, stabilize into repeating geometries capable of storing and releasing energy. They call them self-coded lattices. The term echoes back to the Atlas lattice seen in telescope data. The idea catches fire beyond academia. Documentaries, podcasts, and think pieces call 3I Atlas the first self-writing object. The phrase divides scientists. Some think it's metaphor. Others think it might be literal. By late 2027, construction begins on 2 space-based AI observatories designed to scan for interstellar objects continuously. Each one combines machine learning and quantum interferometry, capable of detecting anomalies months before they enter the inner solar system. The technology owes its existence to 3I Atlas. And somewhere in the background, deep in archival JWST data, an intern spots a faint signature from the final flare in February 2026, the 20-minute rebrightening before it vanished. The spectrum isn't random. It's structured. 5 narrow peaks, evenly spaced in logarithmic frequency. No known molecular transition matches them. The data is triple-checked. Instruments confirmed stable. The pattern stands. No one publishes it officially. Not yet. The implications would demand more than words. But the file circulates quietly between institutions. A new name appears in its metadata: 3I Atlas Event Code 09A Harmonic Burst. Somewhere beyond Pluto's orbit, the traveler moves in silence. The Sun now just another star among many. Cosmic rays wash over its crust again, erasing what little warmth remains. Beneath that shell, something waits. Perhaps dormant. Perhaps observing. Perhaps remembering the brief moment when sunlight woke it near a small yellow star and made the galaxy look its way. It will keep drifting for ages. Maybe another billion years. Maybe forever. Until it meets another sun. Another world. Another species that looks up and asks the same question. Was it alive? Was it built? Or is the difference smaller than we think?